Well, welcome to Fiddly Bits. Today's video is going to show you how to download the code, upload it to your Arduino, and then wire this Cylon LED demonstration. The Cylon LED demonstration is a good way to learn how to do a for loop, which is what controls the LEDs in this case. We have a for loop going from a low number to a high number, and then a second for loop going from a high number to a low number. I think it's 13 down to 6 or so. Yeah, that's the same as the port numbers. So this is a great way to introduce the learner to for loops and how to show them how to control multiple pins on the Arduino. So let's move over to the computer and look at where you can get the example for this from and how you can load it onto your Arduino.
Hello and welcome to my desktop. At this point, we want to walk through how this program works just briefly and some of the reasons for programming it this way. Before I get started, what I want to tell you I don't want to do, and that's we're going to look at the example they provide. So if we go to examples and control, and we look at we look at for loop iteration. I already have it up, so let me bring that over. You can see that they do the same pin mode as we do, this pin and output, but they do it inside of a for loop. So that, presupposes that we already know how a for loop works, and we're trying to teach a for loop. So I leave the for loop for the body of the loop of the Arduino sketch, so that it's a little bit easier to understand. So let's go through and look at, so this code is available to you. Now my wiring is going to be pin 6 to pin 13 because pin 13 is often used as a LED because the default is an LED. So I like to include that in anything I use with LEDs. At any rate, let's go back to the math code print sketch and see what that looks like. So you see I very explicitly set each pin for output, so even a young student can understand what's happening here fairly easily. And I try to comment it in full text and with some explanation. It's often helpful to have comments along the way, but it also can make it hard to read. So in the body of our loop, you see the first for loop, where we go from pin 6 to pin 13, and we write it high, we wait a brief amount of time, and then we write it low. So it's just a blink. And then so this loops through and goes to the next, starts with 6, loops through, goes to 7, 8, 9, until it gets to 13. So less than or equal to 13. It's incremented by x++. So x++ is a C convention, I believe. It might be C++. It means plus means increment x by 1. So then when that's finished, we decrement it and do the exact same thing from 13 down to 6, decrementing x one at a time. We turn the light on, then we turn it off. So also in the code, I've included some other coding activities, ways to wire, and some advanced ideas, which will be the subject of future videos. So the next thing you need to know how to do is to load this to your Arduino. So we do that by picking the Arduino that's ours. And this will be different if I'm on a Linux computer, so it'll be different if you're on a Windows. But you need to pick the port, and you can see mine's on this ACM1. So yours will probably be USB or something like that. So once I pick the port, I can check to see if I've got it by doing a get board info, and it should return some information about your Uno. And then finally, I can check to make sure it compiles, or I could do compile and upload in one stroke. And you can see I've enabled verbose messaging instead of just the basic messaging, so I know a little bit more of what's happening. You probably won't have that turned on. So it's done, and by looking over there, I can see our code is actually running. Now, so you can also do this in the Arduino Create. Let's go over and look at Arduino Create. I think I have that up here. I think I might have one with a, nope. So that's actually, let's talk about this next. This is where you can get my copy of the code It's at mathcodeprint.com, and it's in Arduino project. So you can see it's called Arduino Cylon. You can see it's pictured here. Now my wiring is in the video is going to be slightly different from this. This is just artwork. But you can get the, if you go into the article, you can get, let's see, my website is a little bit slow. You can get the Fritzing diagram for this, plus the code right here. So this is where you can get the code for the Cylon project. And you can see we have the Cylon project there, and later on the video will be listed in this as well. So now let's go over to the Arduino editor here, and I think I have a copy of this in my clipboard. Yep. So there's my for loop that you saw before, and I'm going to rename this to MCP Cylon. And click OK. So if you want to copy this, I think I can share from here, but I don't think I can. I don't think I can just make this public, unfortunately. So we're not connected because that's because our plugin is paused. So I'm going to go over to my toolbar and pause my plugin. So you will need something called the Arduino plugin for this. For Windows, it's free. It's the Arduino Create Agent, and you can get it from the same place. You can get that from the create.arduino.cc. So let's bring that up again. Oops, I want to go to. Nope, I'll get it. All right, so now that I can see I'm connected, you see it's connected to the exact same one locally, and that's what the agent does. And I can just load that to my board from here. So it works in very much the same way. You see all the elements are the same. We have the code. We have our different sketchbooks here. We can open a monitor here. So you can see this is a serial monitor, although my current sketch doesn't send anything to the serial monitor. You have all the examples and more that are available here. So you can see we have control and for loop iteration, and that's the example I showed you before. So now that you know how to upload it and you know where the code is, let's go back and learn how to wire it.
Okay, so let's first slowly take out everything, and I'll sort of talk about it as I take it apart, but then we'll just reassemble it. And we will try to follow some column conventions, so I'm going to try to notice them as I take it apart too. So we'll just take all of these out, this component, and so I have them wired in alternating colors. This makes it a little bit easier to see what you're doing. So let's remove those. So that's pin 13. And it goes all the way down to pin 6. I'm just going to pull those all out at once. Okay, now I can set the Arduino aside a little bit. So what you'll notice in these is that it's in every third pin. So from 22 all the way down to 1. Well, except for 1, because it's already pulled down out. So let's get those out. And they match up with the LEDs, so it's not hard to line them up. So if you see the LEDs, there's we have anode, cathode, blank, anode, cathode, blank, anode, cathode, blank. And by blank, I mean this hole right here. See how that one's empty. So every third one's empty. And then you'll see behind those, I've daisy chained these small hookup wires to line up with the cathode. So we're grounding the cathode. And if by using the small hookup wires, we have a lot less wires running all over the place. And then I run it over here, and then it goes to ground. So at the risk of doing this again, I don't want to. Let me just take out 2 of these, and then, and then we'll go back from there. So let me show you as close as I can. So this first one starts in column 2, and then it goes to column 5. And then this one also starts in column 5 and goes to column 8. This one starts in 8, goes to 11, 11 to 14, and 14 to 17. So that matches the same pattern as the LEDs. So this one it'll skip 2 in the middle. Now, this is a less expensive breadboard, and you'll find that these can be more rigid to insert. So I use tweezers to try to help me. Sometimes if you press on one end and then the other, they go in a little bit better, like that one. Yep. And so this one's going to match on 20 and go to all the way over to 23. Yeah, that sounds right. It doesn't want to go in, and there we go. Okay, so now we can just start doing the LEDs. So the LEDs, remember, the if you've seen these videos before, try to put one of these that behaves. We have, and I always try to keep the cathode side on my right, just for consistency, if I can keep it from rolling out. There we go. So we have cathode is the shorter leg, and anode is the longer one. These LEDs don't. Most LEDs have a flat side on the cathode side. And then if you look inside it, it's probably very hard to see on the video, especially if I'm not focused. But the cathode side has a large piece of metal called the anvil, and the anode side has a small piece of metal called the post. So let's insert that with the anode on the left. And you'll see the cathode lines up with the wire that I had previously inserted. And then we'll do that all the way across. So we'll skip one space with the cathode, with the anode on the left. Oops, I almost lied. And the cathode lined up with the ground wire. And then one space. I'm going to leave this setting down now. So one space. So, you know, because we have it organized, it's very easy to put these in. Now, it is critical that you get them in correctly because none of these will light like Christmas tree lights if one is incorrect. And then you have to, you know, try to figure out which one is incorrect. And a trick to that is just shorting it in front of the first one, second, and third one like that. So that's the LEDs, just like that. And then now what we're going to do is we're going to wire the anode side. We'll do that from pin 1 over to 13. And that one should light up because our Arduino sketch is still running. So it should, that one, oh no, it can't light up yet because we don't have any ground. So what we'll do is we'll let's see, how did I do this? Did I have a green ground wire? Nope. So I guess I just did ground from 2 to ground. I don't remember that looking like that, but now it should light up. So now we're looping through, but since these aren't grounded or powered, they're not lighting up at all. So now we'll go from the anode of the second one over. So that's column 4 over to column 12. Now both of those should light up. That's a convenient way to test it as you're going too. Now we'll go the next one to pin 11. And the next one to pin 10. So I do have a mix of wires here. Most of them are square ends, but I also have round end ones. It doesn't really matter as long as they fit together. I do like to have wires of the same length for a specific project. It just makes it look a little neater and less cobbled together. And I think it's easy for the students to assume, or for the learner to assume, that that the colors mean something, and they don't. So I can't stress that enough. The colors don't mean anything. Oh, I remember what I forgot. Sorry about that. So this, as it stands, will work, but these LEDs have no protection. So if there's an overcurrent coming from either of these wires, any of these LEDs can burn out. Now that's generally not going to happen because these pins can only provide 20 milliamps or 40. I'm not sure, I don't remember. So what I'm going to do is I'm going to rehook this wire to ground over here, and then I'm going to use my current limiting resistor. That's 220 ohm, and I'm going to go from column 2 where I have that ground wire over to the, and I'm getting some kind of backfed ground. That's weird. Don't know what's happening there. And I'm going to do that anyway. So there we go. All right, so there's our project, and I hope you enjoy. And if you like these videos, make sure you subscribe. I'll be doing more. I think the next one's going to be on an LCD, on how to hook up and program an LCD. Thank you, and have a great day. Okay, so I one little PS. I did, I was very puzzled at why it still ran while when I took my ground out, because it should stop like that. because I'm breaking the circuit. So the nearest thing I can figure is that this LED, because I have the tape on it, the best thing I can figure is maybe the goo on the tape is slightly conductive. So let's test that out. So so what would happen is it was letting some of the current backfeed to the ground wire, and it was completing the circuit that way. So we should be able to test it by unplugging the ground and then shorting this. Yep. So that was it. So I guess I am affecting my circuit by having the tape on it. Surprise. Okay. Have a nice day.